All right, let's get right into it. We're going to talk about the most important buildings you've probably never even noticed. I mean, they don't have fancy lobbies or amazing skyline views, but data centers, the actual physical backbone of our digital world, have somehow become the single hottest asset in all of global real estate.
And this quote, it just nails the core idea. You can forget about office towers and shopping malls for a second. The new prime real estate, it isn't about location. It's about power. These buildings are the digital oil rigs of our century, and they're busy extracting and refining the world's most valuable resource, data.
And the scale of this is just staggering. The global market, which is already worth around $342 billion in 2024, is forecast to surge to over $500 billion by 2029. We're talking about a market that could nearly double in just a few years, and it's all being driven by this insatiable demand for AI and cloud computing.
So how did this happen, right? How did we get here? This first section, we're going to explore what you could call the real estatefication of data centers. Let's look at how they went from being this niche, kind of nerdy infrastructure play to a core asset that every major institutional investor now desperately wants a piece of.
You know, the crucial thing to understand here is security. While traditional office buildings are really struggling, data centers offer something investors absolutely crave: stable, long-term cash flow. I mean, we're talking about 10 to 15-year leases with the most creditworthy tenants on the planet, the big hyperscalers like Amazon Web Services, Google, and Microsoft. It's one of the safest bets in property today, for sure.
Now, it's important to get that there are really two different worlds here. On one side, you've got what's called retail co-location. Think of it like a multi-tenant office building, but for servers, where smaller companies can lease just a single rack or a cage. But on the other side, you've got wholesale, and this is where the giants play. The hyperscalers lease entire buildings to power their cloud services, and they benefit from these massive economics of scale.
And that stability, well, that leads us directly to our next section, the gold rush. Because we're going to follow the money and see just how much institutional capital is flooding into this space, chasing the absolutely astronomical growth that's being fueled by AI.
Okay, so what's really interesting on this slide is the performance. Just look at the total returns over a 5-year window, 77%. I mean, that's outperforming most traditional indexes. And check out Europe. Investment there is projected to grow 44% year over year, and a big part of that is driven by data sovereignty laws, which basically require data to be stored locally. The driver for all of this? The AI infrastructure boom.
And this isn't just some passing trend. It's a fundamental shift in conviction. Look at Blackstone, one of the world's biggest property investors. Since early 2023, they have poured over $16 billion into data centers. That is more than they've invested in any other property sector. When the so-called smart money makes a move that big, you know the game has changed for good.
But you know, this story is bigger than just Wall Street returns. In this next section, we're going to see how the narrative really escalates, from a financial boom to a matter of geopolitical strategy. Because compute power is, quite literally, becoming the new currency of global power.
This quote from Grok's CEO, Jonathan Ross, just perfectly captures this new reality. For decades, nations have built their entire foreign policy around securing energy supplies, right? Well, Ross argues that we've entered a new era where securing access to raw computing power is just as critical for a nation's economic survival and its defense.
And this has given rise to this really powerful new concept, sovereign AI. The idea is simple, but it's also profound. To be truly independent in the 21st century, a nation can't just rely on another country's cloud infrastructure. It has to own and control its own physical AI infrastructure, the data centers, the networks, the whole shebang.
And that has sparked a global compute arms race. The numbers are almost hard to wrap your head around. We're seeing corporations like Amazon spending $100 billion, but now we're seeing entire nations getting in the game. Japan has a $65 billion national AI budget, and Saudi Arabia is committing over $30 billion. This isn't just business anymore. This is national strategy.
So why all the crazy spending? Well, it's because AI has fundamentally changed the physics of data centers. A traditional server rack might draw, say, 8 to 12 kilowatts of power. But a rack of GPUs training an AI model? We're talking 40, 50, even 100 kilowatts. That tenfold increase in power density means the old buildings just won't cut it. You need entirely new designs with advanced liquid cooling.
And this brings us to the final and maybe the most critical section of all. All this explosive growth is running headfirst into a wall of physical limits. The biggest challenge for the future of AI isn't the algorithm, it's the electricity grid.
So,
The crucial question is this: where is all the power going to come from? We're building these data centers at a record pace, but the electrical grids that are supposed to power them, well, they're already strained. The industry is facing a really hard bottleneck in the next few years.
And it creates this incredibly difficult trade-off between two very scarce resources. Operators can use what's called evaporative cooling, which is more energy efficient, but it consumes millions of gallons of water. That's a huge problem in dry regions. Or they can use air-cooled systems, but those are way more power-intensive, which puts even more strain on the grid. There's just no easy answer here.
And this presents a massive carbon dilemma. For institutional investors who are committed to net zero goals, this is a real problem. The annual carbon footprint of just one large data center can be equivalent to 100 modern office buildings. I mean, how do you reconcile that with building a sustainable portfolio?
So the industry's answer is to try and flip the script, to stop being just a consumer of energy and start becoming a producer. Data center operators are now some of the biggest funders of new renewable energy projects on the entire planet. But it's not a simple fix. Integrating huge solar and wind farms creates its own problems for grid stability. That's why many are also looking at 24/7 carbon-free power, like next-gen nuclear, hoping to build it right next to their data centers.
So the main takeaway from all of this is a complete redefinition of value in real estate. It's not about the building anymore. It's not about the location or the square footage. The most valuable asset is secured, long-term access to power. Value, from now on, is measured in kilowatts.
And that leaves us with a final provocative thought. As we rush to build this incredible AI-powered future, we're building it on a very physical foundation of concrete, steel, power lines, and water pipes. So the question we all have to ask ourselves is, what is the true physical cost of our digital world?